Welcome to Inspire Lens. Today we are discussing an important question that many students and parents have. Is mechanical engineering dead or is it actually underrated? Because computer science, AI, and IT have become very popular, many students are confused about whether mechanical engineering is still worth choosing. In this video, we'll look at the reality of the branch, the challenges, modern career opportunities, required skills, and who should or should not choose mechanical engineering. The short answer is mechanical engineering is not dead, but it no longer is an automatic career path. The complete answer is simple. Mechanical engineering is not dead, but students cannot treat it as an easy shortcut anymore. Earlier, many students believed that simply completing the degree would automatically lead to a good core job. That is no longer true for most students, especially in average colleges. But the branch is still strong when it is combined with modern tools, practical projects, internships, communication skills, and industry exposure. Mechanical is still relevant in machines, manufacturing, energy, automation, electric vehicles, HVAC, design, maintenance, and industrial operations. So, the main message is do not choose mechanical engineering passively. Choose it only if you are ready to build skills along with the degree. This question become popular because students and parents are comparing every engineering branch with computer science and IT. In many colleges, computer science and IT branches show higher placement numbers, better starting salaries, and more visible recruiters. Because of this, traditional branches like mechanical, civil, and electrical often look weak. Another reason is that core mechanical hiring is not equally strong in every college. Some colleges have good manufacturing, automotive, and design recruiters, while many others mainly bring software and service companies. Salary comparison also creates confusion. Entry level core mechanical salaries may look lower than coding heavy roles, but the biggest issue is skill gap. Students who complete the degree without tools, projects, internships, or communication skills often struggle. This creates negative stories about the branch. It is important to understand the difference between a branch being dead and a branch being changed. Mechanical engineering is not dead. What is declining is the old expectation. Take admission, pass exams, get a degree, and automatically get a secure core job. That path is becoming weaker. The new formula is different. Students need stronger mechanical fundamentals, digital tools, domain exposure, real projects, internships, problem solving skills, and communication. So, the correct conclusion is this: mechanical engineering has changed from a default career path into a skill led career path. Students who understand this change can still build a strong career. Students who ignore this change may face difficulty. Many students think mechanical engineering is only about engines or old machines, but the field is much broader. Mechanical engineers design, analyze, test, improve, and maintain systems, equipment, machines, products, and industrial processes. They may work on computer aided design, product development, thermal systems, manufacturing lines, quality improvement, maintenance, reliability, HVAC systems, turbines, pumps, batteries, medical devices, and many other areas. A mechanical engineering may design a part, test a prototype, solve a manufacturing defect, improve energy efficiency, or support plant operations. That is why mechanical is considered one of the broadest engineering branches. The challenge is not that this field is small, the challenge is that students must choose a direction and build relevant skills. To understand the global direction, we can look at labor market data such as the US Bureau of Labor Statistics. This data is US specific, so we should not directly copy it for Indian placements or Indian salaries. But it helps us understand whether mechanical engineering as a profession is disappearing or not. According to the data used in this slide, mechanical engineering remains a recognized occupation with a large employment base, projected growth, and regular job openings. The important lesson is this: mechanical engineering is not disappearing, it is evolving. Mechanical engineers are still needed, but the nature of work is changing because of automation, electric vehicles, energy efficiency, advanced manufacturing, digital tools, and data driven operations. Mechanical placements feel weak in many colleges for a few reasons. First, The supply of mechanical graduates is high. There are many colleges offering mechanical engineering, so average profiles do not stand out. Second, campus hiring is uneven. Top colleges attract better core companies, automotive companies, design firms, manufacturing recruiters, and R&D opportunities. Average colleges may not get the same quality of recruiters. Third, industry expects job readiness. Companies prefer students who can read drawings, use CAD tools, understanding manufacturing processes, solve problems, and communicate clearly. Fourth, many students prepare too late. They start thinking about internships, projects, and skills only in the final year. For mechanical, that is usually too late. A strong mechanical profile must be built gradually from the first or second year. One common complaint is that mechanical salaries are lower at the entry level compared with computer science or IT roles. This can be true in many cases, but a lower starting salary does not mean the branch is dead. Mechanical careers often reward depth, experience, domain knowledge, and problem ownership. A trainee engineer may start with drawings, shop floor learning, maintenance support, quality checks, or production understanding. After a few years, the student may move into design, quality, maintenance, projects, operations, energy, automation, or technical sales. Later, experienced mechanical engineers can become lead engineers, managers, consultants, specialists, or domain experts. The key advice is compare career paths after 5 to 8 years, not only the first offer. But at the same time, do not ignore the starting salary. Build skills early to improve your first opportunity. Mechanical engineering is still relevant in many important areas. In electric vehicles and batteries, mechanical engineers work on thermal management, battery packaging, testing, manufacturing, safety, and plant equipment. In automation and robotics, machines still need mechanical design, tooling, sensors, conveyors, fixtures, and integration. In HVAC and MEP, buildings, malls, hospitals, data centers, and factories need mechanical systems for cooling, ventilation, energy efficiency, and comfort. In oil and gas and process industries, mechanical engineers support rotating equipment, static equipment, piping, maintenance, reliability, inspection, and operations. So, the real question is not whether mechanical exists, the real question is whether the student is preparing for the modern version of mechanical engineering. Electric vehicles are a strong example of how mechanical engineering is changing. Many people think EVs are only about electronics, software, and batteries, but mechanical engineers also play an important role. Battery packs require mechanical packaging, enclosure design, sealing, safety, structural support, weight control, and vibration protection. Thermal management is also very important. Batteries must operate within safe temperature limits. That means cooling systems, heat transfer, airflow, liquid cooling, and temperature control becomes important areas. Manufacturing and testing also requires mechanical knowledge. Fixtures, inspection methods, assembly processes, quality checks, and validation are all connected to mechanical engineering. So, EV growth does not eliminate mechanical roles, it changes the type of mechanical skills required. Automation and robotics are another major growth area for mechanical students. Modern factories need people who understand machines, production flow, mechanical systems, and also basic digital tools. Robots, conveyors, CNC machines, automated stations, sensors, grippers, and fixtures all require mechanical design and integration. Mechanical engineers can help improve speed, reduce downtime, improve quality, reduce waste, and make production safer. But this field requires cross functional thinking. A mechanical engineer may need to work with electrical engineers, software teams, production teams, quality teams, and maintenance teams. This is why students should not think in a narrow way. Mechanical plus automation knowledge can become a very strong combination. HVAC, MEP, and energy efficiency are very practical and long term career areas for mechanical engineers. Every large building needs mechanical systems. This includes offices, malls, hospitals, airports, hotels, data centers, and industrial facilities. HVAC work includes heat load calculations, ducting, ventilation, chilled water systems, air handling units, comfort control, and indoor air quality. MEP coordination means mechanical systems must be coordinated with electrical, plumbing, fire safety, and architectural design. Energy efficiency is also becoming more important. Buildings and factories are under pressure to reduce energy consumption and improve sustainability. This makes HVAC and energy systems a stable career path for students who like applied engineering. One major career track in mechanical engineering is design, CAD, and simulation. This path is best for students who enjoy visualizing parts, improving products, solving technical constraints, and working on product development. Typical roles include design engineer, CAE analyst, product development engineer, and R&D engineer. Students interested in this path should learn at least one CAD tool deeply. They should also understand drawings, materials, dimensions, tolerances, and basic simulation thinking. A good portfolio can make a big difference. For example, a student can design a bracket, gearbox casing, heatsink, fixture, or mission component. The portfolio should show the CAD model, drawing, material choice, constraints, cost logic, and testing approach. This is much stronger than simply writing SolidWorks certificate on a resume. Another important career track is manufacturing quality and operations. This path is good for students who like factories, shop floor work, process flow, practical problem solving, and continuous improvement. A manufacturing engineer works on production methods, tooling, cycle time, process capability, layout improvement, and production efficiency. A quality engineer works on inspection, defect analysis, root cause analysis, standards, customer complaints, and defect reduction. An operations analyst or production planning role may involve Excel dashboards, production data, cost data, and planning tools to improve throughput, operations, production, and reduce delays. This path is very practical. Students who are comfortable with real factory environments can build stronger careers here. Maintenance, reliability, and energy are very important in industries where equipment is expensive and downtime is costly. In many factories, refineries, chemical plants, power plants, and manufacturing units, mechanical engineers help keep equipment safe, efficient, and available. Rotating equipment includes pumps, compressors, turbines, motors, alignment, vibration, lubrication, and reliability. Static equipment includes pressure vessels, tanks, heat exchangers, piping, valves, and inspection basics. Energy systems includes utilities, steam, cooling water, heat transfer, power systems, and energy saving projects. This path is suitable for candidates and students who like troubleshooting and real industrial systems. It can also lead to strong long term career growth because experience, reliability, and maintenance engineers are valuable. A mechanical student should not depend only on the degree. The student should build a skill stack. The foundation is still important: mathematics, physics, mechanics, thermodynamics, materials, manufacturing, and design basics. Then comes the software tools: CAD, CAM, CAE, Excel, dashboards, and basic Python or MATLAB. Then the student should choose industry exposure: EV, automation, HVAC, manufacturing, energy, quality, maintenance, or design. After that, proof is needed. This means projects, internships, competitions, portfolio reports, and real examples of work. Finally, soft skills matter. Communication, presentation, teamwork, report writing, and safety mindset are very important in mechanical careers. The winning student is not the only with marks. The winning student is the one with marks plus skills plus proof. Students often ask, which software should I learn? For design, students can learn tools like AutoCAD, SolidWorks, CATIA, Fusion 360, or Creo. But the key is not to learn five tools superficially. It is better to learn one tool properly. For analysis, students can explore ANSYS, basic FEA, thermal analysis, simulation thinking, and MATLAB basics. For data, students should learn Microsoft Excel properly. Pivot tables, charts, dashboards, basic formulas, and simple data analysis are useful in almost every industry. Power BI, which is by Microsoft, is also important, and basic Python can also help. For professional work, students should understand GD&T basics, drawing, reading, standards, report writing, and presentation skills. The goal is not to collect certificates, the goal is to solve problems using the tools. Projects are very important in mechanical engineering. A good project should show problem definition, design choice, calculations, testing, and learning. It should not be only a model photo or a copied final year project. Design projects can include CAD models, drawings, material choice, and cost logic. Thermal projects can include cooling systems, heat sinks, HVAC load calculation, or energy saving cases. Manufacturing projects can include fixtures, jigs, process improvement, and quality defect analysis. EV or battery projects can include battery pack cooling, enclosure design, or thermal safety concepts. Automation projects can include conveyors, robotic greepers, or sensor integrated mechanisms. Data projects can include Excel dashboards for maintenance, defect, cost, or production scheduling. By final year, a student should target at least three solid projects, one internship, and one clean portfolio PDF. Mechanical students should not wait until the final year. In year 1, focus on fundamentals, basic CAD, engineering drawings workshop, and joining technical clubs. In year 2, start mini projects, learn Microsoft Excel and basic data handling, and understand manufacturing basics. In year 3, focus on internship, specialization, simulation basics, Python or MATLAB basics, and stronger projects. In year 4, build a portfolio, prepare for placements, improve interview skills, and apply for role specific opportunities. The key message is this: mechanical employability compounds over time. Small efforts from year 1 become a strong profile by year 4. Final year panic is not a good strategy. Mechanical engineering is a good branch when the student has genuine interest and the right temperament. A good fit student usually likes machines, vehicles, engines, manufacturing, software tools, energy systems, HVAC, robotics, or physical products. The student should also be comfortable with physics and mathematics because mechanics, thermal materials, and design require strong fundamentals. Mechanical also needs hands on learning. Workshops, internships, projects, troubleshooting, and site visits are important. So, mechanical is not only a classroom branch, it is a practical engineering branch. If a student likes physical systems and is ready to build skills patiently, mechanical can be a good choice. Honesty is important. Mechanical engineering is not the right fit for every student. A student should avoid mechanical if he or she only wants coding jobs and has no real interest in machines, energy factories, physical products, or engineering systems. A student should also avoid mechanical if they dislike workshops, drawings, design, manufacturing, practical work, or troubleshooting. Family should also avoid choosing mechanical if they expect a high salary from the degree alone. Mechanical requires extra effort through tools, internships, projects, and skill building. The better decision is to choose a branch based on interest, ability, and market preparation plan. Choosing mechanical only because another branch was not available may become risky if the student has no interest in it. For mechanical engineering, college selection matters a lot. Students and parents should not look only at the college name or overall placement number, they should check actual core placements. Ask questions like which core companies visit the campus, what roles are offered, are graduates getting design, manufacturing, quality, maintenance, automotive, or project roles. Labs are also important. Check whether the college has usable CAD CAM labs, manufacturing labs, thermal labs, workshops, project facilities, and available softwares. Project culture matters. Ask about Society of Automotive Engineers, robotic clubs, formula student, mini projects, industry visits and competitions. Internship access is also important. College near industry clusters or offices may provide better exposure. Most importantly, talk to seniors. Ask what role students are actually getting after graduation. Mechanical engineering is a broad degree and it can lead to many directions after the graduation. Students who want technical depth can pursue MTech, MS, or specialization in design, thermal manufacturing, robotics, aerospace, automotive, or energy. Students who want business or management roles can consider MBA in operations, supply chain, product management, project management, or technical sales. Students interested in public sector or government routes can consider GATE, PSUs, engineering services, state government roles, and technical office roles depending on eligibility and vacancies. The benefit of mechanical is flexibility, but the risk is lack of focus. This is why students should start identifying their direction by third year. The future of mechanical engineering will not be isolated from technology. Mechanical students cannot ignore AI, data, digital tools, automation, green energy, and sustainability. Even if a student does not become a software engineer, technological literacy is become important in almost every technical field. Analytical thinking will also remain very important. Quality control, operations, safety, resilience, maintenance, and process improvement all need problem solving ability. The green transition is also creating new opportunities in electric vehicles, renewable energy, energy efficiency, sustainable manufacturing, and climate related engineering solutions. So the lesson is clear. Core engineering does not mean old fashioned engineering. Core engineers must become digitally fluent. So, what is the final verdict? Mechanical engineering is not dead, but mechanical engineering without skills, projects, direction, and practical exposure is risky. The branch becomes valuable when it is combined with CAD, automation, EV, HVAC, manufacturing, analytics, communication, and strong fundamentals. Students should choose mechanical only if they have interest in physical systems and are ready to prepare seriously. Parents should not compare only first year salary. They should look at the long term career fit, student interest, college quality, and skill building plan. The final message is choose it with interest, prepare with discipline, and build proof from year one. Before closing, one important note. This video uses broad labor market and technology trend sources such as the US Bureau of Labor Statistics, the International Energy Agency, and the World Economic Forum. These sources help us understand the overall direction of mechanical careers, EV growth, future skills, and technology trends. But students and parents should not treat this as a guarantee of salary, admission, or placement. Indian college placements, local salaries, and job opportunities must be checked college by college and city by city. The purpose of this video is career education and practical guidance. Thank you for watching. Follow Inspire Lens for more practical guidance on engineering branches, skills, colleges, and career planning.